here. Okay, meanwhile, I'm going to share my screen. Okay. All right, can you all see my screen?
Yep.
All right, let's bring up the canvas. And looks like the stream is not going. Preparing to live stream. Why is it not streaming? Connection has timed out. Try again. Try that again. I have pretty strong network connection. I don't know why. All right, the stream doesn't want to go. All right, so I'll just record on Canvas and then I'll upload it to the YouTube channel later, I guess.
The stream on the YouTube looks good for me.
Oh, it does.
Yeah.
It says here just preparing to live stream the meeting. That's what it says on my side.
Interesting.
And then it says timeout. All right, I don't know if I'm going to close the window. Maybe it is working, and I just, it's just telling me the wrong thing here. All right, I'm going to close that. Let me know if it's still streaming. Is it still streaming? Did it stop? Well, you let me know. In any case, it's recording on Canvas, so I'll be able to upload it a little later. Let me get the chat going here as well. Okay. All right, let's get going. All right, let's see. So we're wrapping up week number 8. And so we start discussing the content of week number 8. We started talking about it late last week, right? We really talked about it in earnest this last time we met on Tuesday, where we discussed mapping relational data to object-oriented data, and how there was several challenges on how to do that, and that doing it manually is fairly laborious and error-prone, and that it's better if we try to use instead tools that are written to do this for us, right? So instead of us doing it manually, we can definitely use tools such as ORMs that are implemented for any number of infrastructures or languages or different stacks that are available, and so that's the better solution, right? And the assignment that went out on Tuesday, we demonstrated how we could map Java models to relational models, right? And that's the assignment that you're working on right now. I noticed that there was a couple of comments that there were some errors that were coming up, and I'd like to discuss that real quick. So let's take a look at the assignment real quick again. All right, so the errors that you might be getting are based on discrepancy that might exist between the tables that you're importing from the database and the data model in your Java, right? And I think one of the reasons is that, for instance, the data model in the relational class, in the relational tables, don't have these fields. I'm not sure why. I'm pretty sure I had added them, but I guess they don't. They don't have those fields created and updated, okay? It also, I believe the relational model adds an additional field. I think it's called like handle or something, which is varchar. And so yeah, that complicates things just a tiny bit. It's very easy to get around the error. I did help a couple of students the last couple of office hours, and the solution is really, really simple. And it entails taking a look at this insert statement here. The original insert statement that I had you use had two nulls here, null and null. And so that was assuming that you had first name, last name, first name, and I'm sorry, username, password, first name, last name, and the last one is profile picture, right? And then I was assuming that you would have created and updated, okay? And the data model is slightly different. You don't have the created and updated, so really you don't need these. You would not need those two nulls, but you do have a handle attribute which we don't use here, right? So it's the fix is really, really easy. It's just removing this extra null, which basically says that we want first name, last name, username, password, profile picture, and then null for the handle, which is perfect. Okay, so yeah, so just removing that last null should fix any problems for for this code to work. Let me know if you find anything else. Certainly reach me at you can text me or whatnot, and definitely we can jump in and take a look at it together. But yeah, that should totally work. I worked with a couple of students on office hours yesterday and the day before, and we were able to solve it very, really easy using this this solution. Okay. All right. Let me know if there's anything else that you find. Other than that, the assignment I think is pretty straightforward. Just make sure to read, right, and understand what you're trying to do, and then just think about what you're doing. Okay. All right. Any questions about this? All right. Let's get going then. All right. So modules. Week number 8. Okay. All right. So let's talk about. Let's keep talking about object relational mapping. We talked about it in the context of the assignment, so that we can demo that assignment for you and to get you going. And again, this particular assignment and the next assignment, there's going to be a lot of hand holding. Right? We're going to tell you exactly what to do. Copy this, run this, verify that this is working, and the intent is for you to practice and learn these new technologies. They're a little bit less about actually using the database and talking to MySQL and doing SQL commands and whatnot, right? It's more a little bit more outside of the database. How is it that we use a database to actually start building something, right? Build an application around the database, right? And there's two things, right? One of them is how can I interact with the database and send data, retrieve data, store data permanently, update the data permanently. How can I retrieve it based on some criteria? And that's the focus of this week, right? Where you can, there's two choices, right? One is a very low level library like JDBC, and there's a high level library, which is the ORM and JPA's implementation of object relational mapping. And so that discusses the communication back and forth from an application to a relational database. So that's the focus of this week. The focus of next week is that is in the end, right? You're going to be interacting with some human beings, right? Humans are going to be using your application, so they need some kind of visual representation of the data. If it's a whole bunch of tables, in a tabular format, or some very pretty markety kind of website, or whether it's a phone application, or whether it's a console application, whatever it is, right? The user, us human beings, need to be able to read something, need to be able to interact either with the mouse or the keyboard or some textual information, right? So that's the focus of next week. Next week, we're gonna be talking about, okay, well, so now that you have all this data, how do you build an application that is data-driven, a data-driven application, right? And so that'll be the focus of next week. And we'll build a simple user interface that, again, it'll focus on the very basic, most common operations that you want to use, right? Which is basically, create, read, update, and delete, right? Those CRUD operations. Those are the most common things that you're going to be doing with any data. The other thing that might be also very common is relationships between records. How do you establish relationships between records? Whether a simple one-to-many relationship or many-to-many, right? How do you say that this is a song that is in a playlist, right? Like a one-to-many, a playlist that has many songs, or establish a many-to-many relationship of saying, well, he's an actor that acts in many movies, and a movie has many actors. How do you establish the relationship like a many-to-many relationship, right? We know how to create it in a relational database using many-to-many, right? Mapping tables, association classes, reifying these kinds. So we know how to draw it in UML, right? We know how to implement it in SQL, right? The next step is, okay, well, how do I represent it? How do I retrieve that data, many-to-many data that into memory, into an application, and then how do I represent that in a user interface so that users can actually interact with this? Okay, so today, right, this week is about retrieving, setting, updating, deleting data. Also, today we'll talk about how do you deal with one-to-many relationships, how do you deal with many-to-many relationships. How do you convert that into a data model, an object data model? We know how to represent it in SQL, in tables and mapping tables and foreign keys, blah, blah, blah. We know how to do that. Well, how do you convert that relational model? How do you convert that into an object model? So that's today's focus. And so next week will be, right, so how do you build a user interface around that? Now, user interfaces, I mean, there are dime a dozen options, right? It could be a phone application. It could be a desktop application using, Java widgets, or it could be a Python application, or it could be, any infrastructure we would choose, or any solution we would choose. I'm sure I would only find a small subset of the students who feel comfortable with that user interface, and then the rest would say, well, I don't know. So I'm going to choose one of the more popular user interface solutions out there, industry-wide, and also very, very lucrative. We're gonna give you like a crash course in React.js. Okay, the very basic minimum that you would need to build something useful. I'll give you all the code. You'll mostly be copying and pasting and modifying it to your needs, and hopefully with this week's topic and next week's topics, this will be the beginning of the implementation of your project. All right, we'll talk about the project as well. Okay. Anyway, so that's the plan for today and next week. Any questions? All right. Okay. Let's we talked about we talked about ORMs in the context of the assignment, and today we're going to talk about it a little more, much more formally, right? The actual coverage of the material, right? We showed you how to use it for the assignment. Let's actually cover it formally, right? So let's talk about it. All right, so ORM. So what are ORMs? Basically, it's a mechanism that allows us to map application data to relational databases, right? So where you have in the application, you have classes and objects, those map to the database tables and records, right? Now, there's tons of solutions out there that they are competing for your attention, okay? And depending on the framework that you end up using, whether it's .NET, PHP, Python, Java, whatever network framework you end up using, there will be some ORM solution, right? We happen to be, we have chosen Java. So in that space, there are a few that are prominent. The beginning, the first one of the first solutions in object relational mapping tools was EJB's Entity Java Beans. Everybody hated it. It was an awful solution, right? And it was very, very unpopular. Nevertheless, folks did implement several things. I was one of them. Totally hated it. Hibernate came along, and they came up with a very, very popular solution, and full huge support from the community, and a lot of their ideas that they came up with eventually made it into what today is the standard implementation of the ORM framework in Java. It's called Jpa, Java Persistence Api. Okay, this is the official ORM solution that Sun Microsystems, now Oracle, that's the standard solution, right? The standard implementation, and different vendors, including Hibernate now, are just now providers, right? They implement this standard, right? Just a set of interfaces, right? And that's what we've been using. That's what we introduced last week, and what we talked about it on Tuesday, and we're going to be talking a little bit more today. If you're using Python, certainly Django is one of the more popular solutions that implements an ORM on object relational mapping. If you're in .NET, Entity Framework is again one of the more used standards for mapping objects to relational databases. Cake PHP in PHP. I mean, there's tons of these, and there's plenty of those, right? So we're going to be focusing on the Java Persistence API, which is, again, it's Java's solution for the ORM. I'm looking at my dog, just making sure that she's not peeing. So we're going to be focusing on the Java Persistence API, which is Java's very popular object relational mapping solution, which is going to map classes to tables, right? Object instances in memory is going to map them to stored records in the database. Properties of the class, they're going to be mapped to columns in the database, and SQL data types to object data types. So getting started. So for this to run, right, you'll need a few things, right? You'll need a Java development kit, at least 8 or above, which is most laptops and most will have JDK 8 installed. If not, if you install an IDE such as IntelliJ, it will include the JDK. For more serious programming and development and building, you might need Apache Maven. Although that's pretty serious stuff, right? You shouldn't need Apache Maven for our assignment. You should be okay without it. If indeed you do need it, we'll just help you install it. Definitely, you need the community server. You need a workbench and a full-blown IDE. I'm suggesting IntelliJ Ultimate, but if you prefer to use code or something else, that's fine. It should work as well. So if you're not using IntelliJ Ultimate, then definitely you'll need Apache Maven. Okay. If you're using IntelliJ, then you should not need Apache Maven. So again, pick your poison there. Right. So to get started, I do have a couple of repositories with sample code to get you started. The repository for our assignment already has everything you need. So let's stick to that repository. It has all the source code that you need to get going. We do need to configure the database, right? We need to say, well, we want to connect to MySQL, right? MySQL is running at a particular port, and so on and so forth, which we did already, right? There's a file that we played around with. There's the application.properties, right? The assignment walks you or shows you some of the content in there, right? In the assignment, I believe we did application.properties. Application.properties, yeah, there it is, right? So three of the properties that we care about is, one is the location of the database. Where is the database running, right? Whether it's running locally on your machine or is it running halfway across the world. It also needs credentials to be able to log into the database, right? And so the slides, are just presenting that as well. Okay, you need the host, your username, your password. There's a few other things that are configured in that properties file, which are cool to know, right? But you could get by without knowing it, but it's cool to know. So, for instance, there's a whole bunch of configurations down at the bottom of the configuration file that are very good for development purposes, right? If you're a developer, you would want to know to be able to debug some of the things that are happening here, right? So, for instance, as I showed you last week, when you interact with the database using JPA, it prints out to the console all the SQL commands that it's using to insert or update or retrieve things from the data. It prints it out to the console, so you can actually see the SQL that is going back and forth between your application and the relational database, right? Which is pretty cool. I mean, for development purposes, for debugging, well, that's awesome, right? So you turn that on. You can configure that by turning on these properties at the bottom of the application.properties, right? Now, this is good for development purposes, but for production, when you're done coding, right, and you're deploying this to, you package it for delivery to clients, you would turn this off, right? Because this would flood your console and your logs in your server and with unnecessary data because you're not debugging it. Other things that you can debug is that JPA can talk to any vendor, right? We're using MySQL, but it can really talk to any vendor. It could talk to Oracle, it could talk to MySQL, to SQL Server, Postgre, it could talk to anybody. And each one of those vendors might have different dialects of MySQL, right? They might not be using the very latest SQL is standard, right? They might be using an older one, and the ORM needs to be able to talk all these various dialects, right? It needs to talk Oracle's MySQL, right? It needs to talk Postgres SQL or MySQL's SQL, right? Or SQL Server SQL. There might be slightly different syntax, right, based on who's talking, right? So that's a great thing that you can configure here. Notice that we have configured that. We were talking about MySQL 5, dialect. Also notice that we're turning on smart. Let me move this out of the way. Oh, sorry. Let me move this out of the way. We're turning on improved naming strategy. Improved naming strategy. What that means is that you remember that I said that in Java, right, the naming conventions are slightly different than the naming conventions in SQL, and so you can turn that on whether you want to make sure that those naming conventions stick to the specific infrastructure that you're using, right? If it's Java, you want it to be camel cased. If it's SQL, you want it to be underscore between the words, right? You want it to be all lowercase, right? So this improved naming strategy configures whether you want to be able to map this correctly, right? And things are named correctly, right? Show SQL, that's also for debugging. For debugging, shows all the SQL. They update, okay? And this configures where you want JPA to create a database for you. Last time, hi, can you hear me? Hear me? I don't know if there was on the action.
It's a bit choppy.
Okay. All time or now? Oh, it says pretty bad.
It keeps coming in and out. I can hear you for like a second, and then you seem to freeze. I don't know.
Is everybody can other men maybe in the chat? Also choppy for me. Okay, so it's everybody. All right. So to look for a better place. Well, whole recording is choppy. Let me move. Okay, I'm gonna try another room. Okay, just hold on a second. Okay, can you hear me?
Yes, but it's still a little choppy.
I'm right next to the router. All right. Try a wide version of. Hold on.
I think we're getting about every fifth word, Professor.
All right. I'm gonna connect. Let's see. I'm wired to that. Hi, can you hear me?
Sort of. It's mostly bad when you talk for extended periods of time. You cut it in now.
All right. Will improve directly.
I think it sounds much better, actually.
Yeah, it's definitely better.
Let's- Okay, great. Thank you. All right. So all right. Let me open up the we were using just to illustrate what the topic discussing about configuration. So open up the project playing around with. So this one. And open up, let's see, we were at this one. DB section, okay, yeah. Right, so yeah, we set that configuration to what did it connecting out of resources. So this is I was talking about to configure. Also, yeah, you figure, using what version the data you're connecting to. In our case, a version 17. You might be a much newer one, 21 or 22. And anyway, so let's look to the coding, right? So a lot of that is in the scenes. Administrator probably configuring all instead of you. With looking at a simple example, right, of a table called, right, that it just has ID and title, something trivial like this, and we want to about the mapping, right? Model here on the side, and have then the model, right? And we want to push these two words. That the name fields are similar, right? ID title, ID and title, and also that the data types are all similar, and or var and string. Really, between these two should be really simple. We can of courses in there, right? And we're trying to break is this gap between worlds, right? The relational, call it the objectional impedance. We have that on the model, right? We have the case insensitive, right? It doesn't really care in whether you title capitalize, everything is sensitive, but on the object, it is important, right? Things are certainly, if it have cases, mean different things. Relational model, we have underscores, as in the we have camel, we have plural nouns. Relational world, we have nouns. The object world, we have explicit primary key, right? Where for an object to be unique, you definitely have a primary key as a unique identifier, whereas in the world, that's kind of an overkill, right? You need unique identifier. When you get instantiated, in basically you reside in a unique space memory, which is a point or some some memory space, right? That really makes let's see, this is maybe just and still cutting out. Same as I'm getting like %. I don't know. I mean, this is gigabit. This is like the fastest connect I can from Verizon. Yeah, internet speed. Internet speed. Server. Megabit again. That's Looking for 100. That's it. Yeah, that's pretty low. He says internet's fine. Your internet can be able to handle streaming and HBO if multiple users are streaming, they may run into. Okay, we'll do the best we can. Yeah, there's some difference between these, and maybe it's to YouTube. Maybe I'll have to do that. Let me do that. That's the problem.